Alright, so we're going to be starting a new chapter today. It's going to be chapter 6. We'll do section 6.1 today and tomorrow, and then Thursday will be the quiz on this. So today is April 7th. Alright, and what I would like you to do is on my Google Classroom, I printed out, or I attached a blank note sheet for you. I would like everyone to print that out or copy that in your notes. I'm going to do that in my notes here, but if you just print that out, it'll be a lot easier for you. So this is going to be section 6.1. It's called Graphs of Trigonometric Functions. I don't like that line. It's better. Now, in order to figure these out, we talked about using our special triangles and quadrantal angles. You could just use a calculator. That might be fastest, but I just think it's a good idea to draw these again, just so we could reference them if we need to. And then for quadrantal angles, we know that those are 90, 180, 270, and 360. There's a dog barking here. I don't know if it comes through, but all right, so this is what I would like you to do. We're going to have a column for theta, column for sine, and cosecant, column for cosine and secant, column for tangent, and a column for cotangent. And what we're going to do is we're going to pick, well, I already picked them for you. We're going to plug in theta values. And what I would like us to do first is we're going to do it for sine and cosine. So let me show you what I'm talking about. There's 0, 45, 90, 135, 180, 225, 270, 315, 360, 405, and 450. Now this is already drawn for you, so you shouldn't be copying this over again unless you didn't feel like printing out my note sheet. And what we're going to do is we're going to find the normal trig functions first. So in your calculator, you could actually pause this video and type them in if you want. I know these off the top of my head, so I'm going to go ahead and do it, but I think there's some benefit for you to type in, like type in the sine of 0. It's going to be 0. Sine of 45 is 0.7, and it's 1.70, negative 0.7, negative 1, negative 0.7, and 0, 0.7, and 1. Alright, so you could just type those in if you want. I mean, really, for sine, you could use the special triangles or quadrantal to find 0, 90. Really, you could figure all those out, but we want to use decimals for this. Cosine of 0 is 1, then it's 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, 1, 0.7, and 0. And tangent would be 0, 1, undefined. Negative 1, 0, 1, undefined. Negative 1, 0, 1, and undefined. All right, now to go from sine to cosecant, what we're going to do, because we don't have a cosecant button, is we just do 1 divided by 0, which is undefined. 1 divided by 0.7, which is 1.4. 1 divided by 1, which is 1. 1 divided by 0.7. So you're taking everything in sine and you're dividing it by 1 to get cosecant. for secant, you're taking 1 and you're dividing it by whatever cosine was. Then to get cotangent, you're doing 1 and dividing it by whatever tangent was. So I'm going to do that quickly here. This is going to be 1.4 and undefined. Negative 1.4, negative 1, negative 1.4, undefined. 1.4 or 1. For secant, it's going to be 1, 1.4, undefined. Negative 1.4, negative 1, negative 1.4, and undefined. This is 1.4, 1, 1.4, and undefined. And then for cotangent, 1 divided by 0 is undefined. 1, now this is going to be interesting, I'll skip those. Negative 1, undefined, 1, negative 1, undefined, 1. And I skipped the undefined ones because how do you type that into your calculator, right? So undefined means that you have 0 in the bottom. So if we take the reciprocal to get cotangent, 0 is going to be on top. And for any time tangent's undefined, that means cotangent is going to be 0. All right. And then to finish up class today, what I wanted us to do is we are going to be graphing these trig functions. We're just going to be plotting those points. So there's 6 functions, which means there's going to be 6 graphs. What I'm going to do is I'm just going to copy and paste this 6 times to make things a little bit easier for me. You guys could just use my sheet. 1, 2, 3, 4, 5, and 6. All right, so let's go ahead and graph these. First one I'll graph is the sine function. I'm just going to be looking at my chart, and I'm going to be graphing y is equal to the sine of theta. So if you look at your chart at negative 90 degrees, well, we didn't do that, but at 0, it was 0. 45, sine was 0.7. Then it was 1 at 90, and then 0.7, and then 0, negative 0.7. So we had points that look kind of like this. And if we connect the dots, it's a little hard to connect them on the computer. But you can see we have a wave, right? And we get what's called amplitude from here to the middle. That's called amplitude. Just the same distance from here to the bottom. That's called the amplitude. Amplitude for sine is going to be 1. And it looks like it repeats after every so often, right? I mean, look right here. It goes 0 and it goes up to 1. The next time it does that is right here at 360. And it goes up to 1. Every time it repeats from here to here, that's called period. Period means how often a graph repeats. And it looks like for sine, that period would be 360. Let's graph cosecant. Now at 0, cosecant was undefined. Anytime cosecant's undefined, I'm going to be drawing what's called an asymptote. We've talked about asymptotes before. Those are lines that the graph gets close to. And if we start plotting these at 90, it look like this. At 225, it's negative 1.4, negative 1, negative 1.4. Looks something like this. And this shape is actually parabolas. On the other side, it would look like a downward parabola like that. Whenever we're talking about the amplitude of cosecant, we always say that there's none. Amplitude is only for wave functions. The shape, these were parabolas, alternating parabolas. Alternating means one up, one's down, one's up, one's down. And then the period means how often it repeats. Well, the next time you have a parabola facing up is right here. So we go from right here to right here. And if we copy and paste that, it looks like we get the same graph. It would be up, down, and then 360 degrees later, up, down. So that would be what the period is. The period for this would be 360. I'll summarize this at the end too. Just if you're having trouble with this, just bear with me for right now. The more important thing right now is that you get the shapes of the graph. We're going to do the same thing with cosine. And if we plot our points, it's going to look like this. Right, so you plug in all your points. If we connect the dots, it'll look like this. And just kind of keep it going. So this shape is a wave. We said that the amplitude is from the middle to the top or the bottom. Looks like from the middle to the top or the middle to the bottom is 1 unit. And the period for this looks like next time it starts at 1 like this would be 360 degrees later. Let's go to secant. And for your homework tonight, you're going to be expected to do what I'm doing here, plot the points and see what it looks like. All right, so for secant of 0, it's 1, and then we go 1.4, and then 90 is undefined. It goes negative 1.4, negative 1, negative 1.4, and then undefined. 1.4, 1, 1.4, and then undefined. So we've seen this kind of graph before. Probably going to look something like this. These would be parabolas that are alternating. There's no amplitude unless it's a wave. This is not a wave, so we say that the amplitude is none. And as far as the period, well, looks like it's 1 right here. The next time it's 1 and going up would be right here, 360 degrees later. So all of our periods so far are 360. Let's go to tangent. And if we plot the points that we came up with in the graph, 0, 1, undefined. Then it goes negative 1, 0, 1, undefined. Negative 1, 0, 1, undefined. So we can imagine over here, that's what the graph would look like. Now actually, if we were to pick more points, the graph of tangent would actually resemble a cubic function. What's important to me right now is that you could remember these shapes. So the tangent graph looks like a cubic function. There's no amplitude because it's not a wave. And the period, this one's a little bit different. It looks like from 90 to 270, or from 270 to 450. Every 180 degrees, we actually get the same thing. So this is a little bit different. Or did I draw an extra graph here? I should have drawn 6, right? So let's see here. 1, 2, 3, 4, 5, 6. So this one's extra. All right, let's finish with cosecant. All right, cotangent. So y is equal to the cotangent of theta. Looking at my chart, it's 0, it's undefined. Then it goes 1, 0, -1, undefined. 1, 0, -1, undefined. 1, 0, probably -1, right? So if we connect these dots, it's going to look like a cubic, but it's going the other way. Probably something like that. So this is a cubic graph, just like tangent. There's no amplitude because it's not a wave. And the period for this, how often does it repeat? Well, look, from 0 to 180. 180 to 360, it looks like the same thing. So the period for these are 180. So let's summarize. What I want to do is I'll make a little table with the function, the shape, the amplitude, and the period. Okay. First, let's start with, we'll group the similar ones. So sine and cosine looked like a wave. The way that you graph them is you pick points, type it into your calculator, plot the points, and connect the dots. The amplitude for those functions is 1, and the period is 360 degrees, or 2 pi if we're thinking about doing radians. Other graphs where we had cosecant and secant, that looked like alternating parabolas. There was no amplitude, and we said the period was 360 degrees, or 2 pi if we're in radians. Last functions were tangent and cotangent. Purple looks pretty. The tangent graph looked like normal cubics. The cotangent graphs were going the other way. And every time I draw that, I think it looks like a six-pack. If you kind of look at it sideways, like if here's the head and here's like the legs. But anyway, there's no amplitude for this. And we saw that the period was 180 degrees, or pi if we're in radians. All right, so for homework, you're just going to be asked to recreate the graph. It might ask you some questions about when is sine like 0. The question says, when is sine of theta equal to 0? Well, you would look at the graph. And it looks like sine is 0 right here at 0 degrees. Right here, if you looked at the graph, this was 180 degrees. It looks like sine would be 0 at 0 degrees, and then plus 180 degrees, every 180 degrees. That would be the answer to that. So take a look at the homework. This is what I would like you to try. I'll review it tomorrow. But on page 305, I would like you to please try numbers 20 to 42 even. Try them all. Make sure you attach a picture of your work to this assignment. We'll go over it tomorrow. This is really it for like lessons. Tomorrow we're just going to be doing a worksheet and we'll review some more. And then, of course, Thursday, you know that that's your quiz. Thank you very much. Have a nice day.